Okay, so we've got one more application here. It says a toboggan travels from point A at the top of the hill to point B at the bottom. Because the steepness of the hill, man, there's a lot of typos here, varies, the angle of depression from A to B is only an approximate measure of the hill's steepness. We can, however, think of this angle of depression as representing the average steepness. If the toboggan travels 130 meters from A to B and the vertical descent AC is 50 meters, what is the approximate angle of depression? So basically, you're just saying, well, imagine that this hill is really just a perfect triangle. And you can get a good estimate for the angle of depression. Remember, the angle of depression, this is where you have to be careful. You have to think about your horizontal, and your angle of depression goes down from the horizontal to the hill. So this is the angle of depression, not this. Horizontal, down. All right? They tell us that it travels 130 meters from A to B. So this is 130 meters right here. And then it tells us that the vertical descent AC is 50. So it's going to go 50 meters down. All right, so we're looking for this angle right here. And so we could just redraw AC over here. We know that this height right here is 50. And then just use this triangle to find A. Or we could use the triangle we had and find B and realize that B is just the alternate interior angle when AB cuts these two parallel lines. But it doesn't matter. Either way, you're going to get the same thing. We're looking for that angle though, not this one. The angle of depression goes down from the horizontal. So right here. All right, so we're going to want to use sine because we've got the hypotenuse and we've got opposite. So the sine of A, this angle here, is going to be 50 over 130. So since we're looking for the angle, we have to use inverse sine. So 50 divided by 130. And then we take inverse sine, and we get that angle A is about 25 degrees. So that is the approximate angle of depression.